to talk about transformations. And when we talk about transformations, we're dealing generally with y equals a times f of x minus h plus k. And actually, we're going to make that a little bit more nuanced. And it's going to be y equals a times f of bx minus h plus k. So we're going to have four different things that are going to affect what our parent function is going to look like. We're going to have a, b, h, and k. But before I get into each of those, I want to spend a little bit of time and just talk about the concept of a parent function. The reason we use the word parent function is because a lot of the way we look is determined by our parents. Our color, maybe our hair color, maybe our eye color, lots of our facial features, sometimes a lot of the way we act. A lot of those are determined by our parents. We're not identical copies of our parents, so not equal, but there's a lot of similarities. It's the same with functions. When I have functions that are parents, I'm talking about, for example, in this function here, my parent function is a function x squared. It's the highest value, the highest exponent of x in my function written in standard form. So if I look at my function, my parent function, that's my parabola. Pretty typical parabola of x squared. When I look at, let's call it the child function, that's an interesting term for it, it's very similar. It's changed, it's shifted around a little bit, it's gotten a little bit narrower, but some of the behavior is really still the same. For one thing, it's a parabola. It's the same color here. It's a parabola, that's the red one right here. Just like my other one is a parabola. Also, in this particular parabola, I have the behavior, end behavior is going up. Like in my parent function, it's going up. And actually, it's not really so much a matter that it's going up, it's that it's going in the same direction. It's a little bit easier to see, I think, with a function like x cubed. So let's look at my parent. Here's my parent function, x cubed. And then here's the child function. Also, the parent is x cubed. Well, now we got a little bit difference here. You can see in my x cubed, it's kind of like what I call a little squiggle shape. It's going right here, and it's going up. And actually, this function has behavior where it's down, up behavior. The ends are going in opposite directions. Well, on my red one, I have a similar kind of a squiggle. I mean, it's a little bit different. And that little bit of a difference right here, by the way, whoops, there we go, is being caused by the fact that my x squared is trying as hard as it can to turn this into a parabola. But x squared is a lot less powerful than x cubed. So the genes, so to speak, from x cubed are dominating this function. And we have the same thing, where the ends go in opposite directions. So when we're talking about transformations, we're talking about what are the different features inside of a more complicated function that are going to impact the parent function and change the way that it looks. The next thing that I want to talk about in relationship to this is I like the idea of a function machine. So here's my function machine. How would that go? Like that, like that. So here's my function machine f. And when I take an x and I drop it into my function machine, it goes into the function machine, it gets squiggled around and does whatever it's going to do, and and it pops out an f of x. So I put in an x value, it comes out a y value, and inside this middle here is where all this stuff is happening to it. When I look at my transformations, y equals a times f of bx minus h plus k, I want to call attention to a couple of things. One is that the a and the k are outside of the function. Well, outside of the parent function. The b and the h are inside. So that's going to make a difference as to how we look at these transformations.